Okay, in this lesson class, we're going to continue where we were. We're going to say that we have two coordinate points, and we're going to find the vector that goes from one to the other. So that we're going to notate that by saying the vector AB with the arrow pointing towards the B, and that's really easy to calculate. So AB, these are simply the coordinates of B minus the coordinates of A. So this would be 2 minus 1, 3 minus 0, and 4 minus negative 2, which is the vector 1, 3, 6. Alright, so that's going to be used when we find equations of lines. So another type of thing we need to be able to do, so if we take a vector, and I'm just going to pick one, I'm going to say it's a vector 2, 1, 4. Let's say we want to find the unit vector in the direction of V. Okay, so this is a real common thing for us we'll need this when we talk about the scalar projection and distances. So first off, you need the magnitude of V, which is the square root of 2 squared plus 1 squared plus 4 squared, which most of the time is root 21. Okay, so we need the magnitude, and then the unit vector in direction of V doesn't really have a special symbol or name or anything. It's just V divided by times 1 over the magnitude. Okay, so in this case we can simply just say 1 over root 21 times the vector 2, 1, 4. Okay, and that's going to be used in a couple places as well. The last thing I want to talk about, the standard basis vectors. And I'll talk about 3D, but you can just take the first two sort of and make 2D. So the standard basis vectors would be the following vectors. So the vector I typically don't put the arrows above these guys. So that would be 1, 0, 0, J, which would be 0, 1, 0. Of course, in 2D it would be 1, 0, and 0, 1. That would be it. But in 3D, we have another one, K, which is 0, 0, 1. And if you think about how 3 spaces is done, you have an X, Y, and a z-axis, and these vectors just go, I would be a vector there, J would be a vector there, and K would be a vector there. These are all unit vectors, and they're all perpendicular to each other. So they're what we call an orthonormal basis. So those are kinds of nice things to have. Alright, so what's significant about the standard basis vectors? Any vector can be written as a linear combination of the standard basis vectors. So if I want to take the vector 2, negative 3, 5, I can also write that as 2i minus 3j plus 5k. Now, I'll just say I don't particularly like writing the ijk that much form, but there are some books and places where they specifically like to use that. I'm thinking physics mostly. Almost exclusively. Okay, that's it for this lesson.